Okay, let's start with the basics. Test automation is basically using software to run tests for us automatically. Think of it like having a robot do your testing. It's hugely beneficial because it speeds things up, reduces errors, helps us catch bugs earlier, and make sure we don't accidentally break existing features. Okay, so let's talk about what we gain and what we need to watch out for when it comes to test automation. The big benefits are that it can drastically improve your efficiency. You'll be able to automate those tedious, repetitive tests, which frees up your testers to tackle more interesting and challenging work. It also means fewer mistakes because the automation runs consistently, unlike a human tester who might get tired or miss something. Thus, you'll get feedback much faster, which is great for keeping development on track. And of course, it allows you to test a wider range of scenarios consistently. However, there are some hurdles too. There's an initial investment in terms of time and money. Getting your automation system set up takes effort. You also need to constantly maintain those tests as the application changes, which means ongoing work. You'll need people who know how to write scripts and use automation frameworks, and it's important to design your automated tests really carefully so you don't get false positives or negatives that can lead to confusion. Let's talk about the different types of automation testing we can use. First up, UI automation. This is all about making sure that when a user interacts with your app, everything works as expected, like buttons click correctly and forms submit properly. We often use tools like Selenium or Cypress for this. Next, there's API automation. This focuses on the behind-the-scenes communication between different parts of an application. Think of it like testing how well those pieces talk to each other. Postman is a popular tool here. Moving on to mobile automation, we're automating tests directly on iOS and Android devices. Appium and Espresso are great frameworks for this. Finally, performance automation is key to ensuring your app can handle lots of users without slowing down or crashing. Tools like JMeter help us simulate that user load. Okay, so let's talk about designing a solid test automation framework. Think of it as building the foundation for all your automated tests. It makes things easier in the long run. A good framework isn't just a bunch of scripts, it's carefully planned architecture that promotes modularity and reusability. We need to consider everything from how we manage test data, right through to reporting our results effectively. Then, choosing the right framework depends on your project, its complexity, and what you want to build for the future. Let's talk about different ways to build your test automation frameworks. First, we have data-driven testing. This separates the actual data you're using from the tests themselves. Think of it like feeding your tests with different information from spreadsheets or files. Then there's keyword-driven testing, where you define actions in a keyword library and link them to your code. Hybrid testing is just a blend of those two, giving you more control. BDD, behavior-driven development, uses a language like Gherkin to describe what the system should do. Finally, we have Page Object Model, or POM, which is all about organizing the user interface into reusable objects, making your tests cleaner and easier to maintain. Okay, so let's talk about picking the right tools for test automation. It's really important to get this right because it can make or break a project. There are lots of different options out there, and frankly, you don't need every single one. We've got programming languages like Python, JavaScript, and Java, each with their own advantages. Then we have frameworks like Selenium, Cypress, and Playwright, which help us structure our tests efficiently. And of course, you'll want a CI/CD tool to automate your testing into your development workflow, along with test management tools to keep everything organized. Just remember, start simple and build up as needed. Don't feel like you have to jump straight into the most complex solution. Okay, let's dive into Selenium WebDriver. Essentially, it's like a remote control for web browsers. It allows us to automate interactions, things like clicking buttons and filling out forms using code. We have a driver, which is the main component, and a WebDriver manager that takes care of browser compatibility issues. We'll be working with elements, those are the clickable bits on our web pages, and using actions to simulate what a real user would do. Now, we're going to get started setting things up so you can begin your automation journey. Okay, let's talk about how Selenium WebDriver works. It's essentially a way for us to tell a web browser exactly what to do automatically. Think of it as three main parts: the web driver itself, that's our main control point. Then we have browser drivers, which are tailored to each browser you want to use, like Chrome or Firefox. And finally, the Selenium server acts kind of like a traffic controller, taking requests from the web driver and getting them to the right driver. It's really a clever system that allows us to automate complex web interactions in a consistent and reliable way. Okay, let's talk about how Selenium finds elements on a web page. We call those elements locators. Think of it like giving Selenium a precise address to locate the specific button, text field, or whatever you need to interact with. We've got several different ways to do this. The most reliable is usually an ID, which is a unique identifier for each element. Then there's name, used mostly for form elements. XPath allows us to navigate the entire HTML document tree based on attributes and relationships. It can be really powerful, but also a bit complex if things change on the website. CSS selectors are often faster than XPath because they use CSS rules. Link text is super useful when you're looking for specific links, and partial link text lets you find elements with parts of their text. A good strategy is always to start with an ID if one's available, otherwise consider XPath or CSS as your backup options. Let's talk about how to tackle some tricky web elements during testing. Many applications use drop-down menus, alerts, and even different windows or frames, which can make automation a little more complex. We'll cover the most common types like drop-downs, where you need to simulate selections, alerts that require handling confirmations and cancellations, and how to switch between frames and windows. And of course, we'll discuss dynamic elements, those that change based on user actions or data updates, and show you some best practices for making your tests more reliable and robust. Let's talk about the page object model, or POM. It's a really important pattern for test automation. Think of it as creating reusable blueprints for each page in your application. The goal is to make our tests easier to maintain and more reliable. Basically, we create classes that represent a specific web page, and within those classes, we store information about the elements on that page, like buttons, text fields, or anything else users interact with. When something changes on the website, we only need to update the page object instead of hunting down all the tests that use it. It makes our lives so much easier. Each page object has locators that identify UI components and methods which simulate user actions like clicking a button or entering text. This structure leads to more readable and maintainable tests. Okay, let's talk about the core tools you'll be using: JUnit and TestNG. JUnit is a really solid foundation for unit testing in Java. It helps you verify that smaller pieces of your code are working correctly on their own. It uses assertions to check if things match what you expect, and organizes tests into test cases and suites. Now TestNG builds on top of JUnit, adding some powerful extra features like running tests in parallel, using parameters to set different inputs, and generating more detailed reports. Think of it as a way to make your testing process even faster and easier. Let's quickly look at the main differences between them, things like how they handle parallel execution and the kind of annotations you use. Let's talk about how we can add extra information called annotations to our tests using TestNG and JUnit. Think of them like little notes attached to your test methods that tell the testing framework what is happening, when it's happening, and even what to do afterwards. TestNG has a bunch of specific annotations like @test for marking your test cases, and others to set things up before or after entire suites or classes. JUnit uses similar concepts with annotations like @before each and @after each for managing setup and cleanup around individual tests. These annotations are key to creating organized, informative, and easily maintainable automated tests. Okay, let's talk about speeding up your test, specifically with parallel execution. Essentially, it's all about running multiple tests at the same time instead of one after another. The key here is that your tests need to be independent. If one test fails, it shouldn't cause others to fail too. To make this happen, you'll need to use a tool like Jenkins or GitLab CI/CD, which can manage and orchestrate running all those tests in parallel. The big payoff: You get much faster feedback loops, meaning you see results quicker, leading to more efficient testing and better overall coverage. Okay, let's talk about data-driven testing. It's all about making your tests much more efficient and comprehensive. Instead of writing separate tests for every possible input, we use DataThink spreadsheets or databases to feed the test script. This means you can run the same test with different usernames, passwords, or whatever data you need, massively increasing your coverage. We'll look at how to prepare that data, how to parameterize your tests so they use those values, and even a quick example in Python using pandas to create a CSV file really handy for organizing your test inputs. Okay, so let's talk about how we report on our automated tests. We'll be looking at extent reports, and although these are really important tools for understanding what happened during your test runs. Extent reports are a solid base. They create detailed HTML reports that give you a great visual overview of pass/fail rates and execution times, and they even capture screenshots when things go wrong. But Allure takes it to the next level. It builds on extent reports by adding features like really rich metrics going beyond just pass or fail to show trends and performance data. Thus, you can create interactive dashboards and organize your tests using labels and categories for much easier analysis. Think of extent reports as the foundation, and Allure as the upgrade that makes those reports truly powerful and insightful. Okay, let's talk about continuous integration and continuous testing. CI is all about getting code updates from developers into a central place very frequently. Think of it as a constant merging process. When those changes happen, the system automatically builds the software and runs automated tests to catch any problems early on. This helps prevent big headaches later. Now, continuous testing goes even further. It's not just about building, it's about testing everything at every stage, from individual pieces of code unit tests to how the whole system works together, integration and end-to-end tests. You might also run performance tests to make sure things are fast and reliable. Essentially, CT makes sure we're catching issues as soon as they arise, not waiting until release. Okay, let's talk about how CI/CD tools fit into test automation. Think of these as your automated testing helpers. They run tests automatically whenever you make changes to your code. We've got a few big players here. Jenkins, which is super flexible and open source, GitLab CI, that lives right inside GitLab repositories, making it really easy for those teams, and Azure Pipelines, Microsoft's offering, especially strong if you're already using their services. Each of these tools helps to automate the process from building your code to running tests all the way through deployment. Okay, so let's talk about version control specifically for test automation. It's a really important skill to have as an engineer. Basically, it's like having multiple saved copies of your code, but with a way to track changes and easily revert back if things go wrong. We're talking Git here. It's the underlying technology behind many other tools. GitHub, GitLab, and Bitbucket are all platforms that make using Git easier and offer great collaboration features. GitHub is probably the most well-known for open source projects, while GitLab and Bitbucket often integrate really smoothly with other development tools like Jira. Knowing how to branch, commit, merge, those are key concepts that will help you stay organized and work effectively in a team. Okay, so as a test automation engineer, you'll spend a lot of time ensuring your tests are built correctly. That's where tools like Maven and Gradle come in. Think of them as the master builders for your automation projects. Maven is really solid. It uses something called the POM, which is essentially one file that tells everything how to be built. It handles dependencies, compiles your code, runs your tests, and packages everything up into ready-to-go artifacts. Gradle is similar but even more flexible because you can write custom instructions using Groovy or Kotlin. It's super powerful for larger, more complex projects. Let's break down a few key differences in this table to help you get familiar. Okay, so today we're talking about automating APIs, super important in modern software development. We've got 3 fantastic tools to help us do that. Rest Assured, which is a Java library and really easy to get started with. Postman, which is a popular tool you might already be familiar with. especially if you like using the GUI for testing, and Karate, which is an awesome open source framework that lets us write tests in plain English perfect for BDD. Each of these has its strengths, so choosing the right one depends on your project's needs and your team skills. Okay, so when we're designing an API automation framework, it's really important to think about the bigger picture. We need a system that isn't just throwing tests at API, it has to be structured and maintainable. First, let's talk about test data. We want a central place to manage all our input values so tests are repeatable. Then we'll look at abstracting away the details of the API itself, ensuring our tests aren't broken when the underlying API changes. We also need solid ways to validate responses and a good reporting system to track what's going on during testing. You might be thinking, how do I actually do this? Well, in Python we can use libraries like request to build reusable functions for making API calls. This is just the starting point. Building a full framework involves careful planning and modular design. Okay, let's talk about how we work with data in test automation. A lot of the information our tests need comes in formats like JSON and XML. They're super common when dealing with API or different systems exchanging data. The key is to parse these files, which essentially means turning them into something our scripts can understand, like a structured object we can easily work with. Parsing helps us grab the specific information we need, validate that everything's in order, and even build tests that adapt based on what the data actually looks like. Okay, let's talk about how we handle authentication when testing API. There are a few common methods: API keys for simple access control, basic auth username and password, but that one needs careful consideration due to security risks. More commonly now, you'll see OAuth 2.0 or JWT tokens being used, which offer much better security. When it comes to testing, we need to make sure our tests verify both successful logins, where a session is created correctly, and failed login attempts, ensuring an error message appears and no unauthorized access happens. Also, if the system uses expiring tokens, we have to test those expiration scenarios as well. And most importantly, always remember to use safe test data and avoid hard-coding your credentials in your tests. Consider using environment variables or secure credential management instead. Okay, let's talk about BDD. It's all about making sure we're building software that meets everyone's needs, not just the developers. BDD is a way of thinking where we describe what the behavior of our software should be in plain language. Cucumber is really the core idea behind BDD. It uses something called Gherkin syntax you'll see given, when, and then used to clearly outline each step. SpecFlow makes this easier if you're working with C# code, while Behave offers a simpler approach specifically for Python projects. Essentially, these frameworks help us write tests that are really clear and understandable by everyone involved: developers, testers, product owners, anyone. Okay, let's talk about Gherkin syntax. It's super important in BDD. Basically, we use this language to write tests that are easy for everyone to understand, not just developers. Think of it as describing what the user should be able to do with the system. It's broken down into features which represent a bigger goal and scenarios which give specific examples of how that feature should work. Each scenario has these key parts: give and sets up the starting point, when describes what action the user takes, then tells us what we expect to happen afterward. And for longer sequences, you can use them to connect steps together to keep things clear and readable. Let's look at a quick example of how it all fits together to define a login feature. Okay, let's talk about bringing BDD into your test automation projects. Basically, with BDD, we focus on what the software should do for the user. Those as I want stories before we even write a single line of code. We then create these clear scenarios in Gherkin, which is like writing tests in plain English using given, when, and then statements. This helps everyone on the team understand what needs to be tested. Next, we turn those scenarios into actual automated steps that our testing tools can run. It's all about collaboration and making sure everyone's on the same page. Remember to keep refining your tests as you go. BDD is a continuous improvement process. Okay, so when it comes to automating mobile apps, we've got a few really popular options out there. First up is Apim. This is fantastic because it lets you test on iOS, Android, and even Windows Mobile all with one framework. It uses something called WebDriver, which is pretty clever. Then you have Espresso, which is Google's own UI testing tool specifically for Android. It's known for being really fast and reliable. Finally, we have XQtest. That's Apple's equivalent for iOS apps. It works wonderfully with Xcode and gives great performance. Think about your project needs when deciding which one to use. Okay, let's get started with building the foundation for our mobile automation tests. First, we need to decide on a programming language. Something like Python or Java often works well. Then, it's time to pick an automation tool. Apim is fantastic for cross-platform testing, while Espresso and XQtest are great for iOS and Android respectively. We'll also need a test runner, such as Selenium, JUnit, or TestNG to actually execute the tests. Finally, let's integrate a reporting framework like Allure or Extend Reports to make sure we get clear and detailed results so we can really understand what's going on. Okay, let's talk about how we make sure our web apps work great everywhere. As a test automation engineer, cross-browser testing is super important. We don't want our website looking broken in Safari, Chrome, or Firefox. Tools like Selenium Grid allow us to run tests on multiple browsers at once, making it much easier. BrowserStack and Sauce Labs are fantastic cloud services that give us access to actual browsers and operating systems. No need for a huge lab setup. They handle all the technical details, so you can concentrate on writing really good test cases. Okay, let's talk about performance testing. As a test automation engineer, knowing what this entails is really important. Basically, it's all about checking how well your application performs under different circumstances, like when lots of people are using it at once. We're not just looking for errors, we want to see how fast things load, how much data the system can handle, and whether it stays stable over time. Some key metrics we watch include response time. That's how long it takes to complete a task. Throughput, which is how much work gets done in a certain amount of time. Resource utilization, like CPU usage, and stability, or how long the application can keep working under load before things start to break down. There are different types too. Load testing simulates what you expect from normal users. Stress testing pushes it beyond its limits to see where it cracks. And endurance tests, sometimes called SIRG tests, involve running for a really long time to catch problems that might not show up quickly. Okay, let's talk about performance testing tools. As a test automation engineer, you'll often need to make sure your applications can handle lots of users at once without slowing down or crashing. We have some fantastic options available. First up, there's JMeter, which is a really common open source tool that lets us generate load and stress tests. It works great for basic HTTP testing. Then we've got Gatli. It's specifically designed to simulate high user loads with realistic scenarios, so we can really dig into response times and how resources are being used. And finally, K6, a newer player in the game. It's super lightweight, scriptable using JavaScript, and works really well alongside our CI/CD pipelines. Okay, let's talk about testing microservices. With so many independent pieces working together, manual testing just doesn't cut it. Automation is absolutely essential for keeping things under control and ensuring quality. We need to be able to scale our tests as the number of services grows, and automation gives us that ability. It allows us to quickly identify problems before they cause issues for real users, and builds confidence in our system's reliability. We'll look at some key techniques like service virtualization, contract testing, which make sure everyone is speaking the same language, and building robust integration test suites. Okay, let's talk about Docker. Essentially, it's like creating a miniature, self-contained computer container for your tests. This container bundles everything your test needs: the code, libraries, and even the operating system. The beauty of this is that you can run the same test on any machine that has Docker installed, guaranteeing consistent results. It's fantastic because it avoids those tricky situations where your tests work perfectly on your local development machine but fail when deployed to a different environment. Plus, it isolates your tests from each other, preventing conflicts and making things much more reliable. And best of all, setting up environments is incredibly fast. Okay, let's dive into containerized test environments, a huge win for test automation engineers. Basically, instead of fighting with different server setups or manually installing everything every time, we package our tests and all their needs like libraries and databases into little self-contained boxes called containers, usually using Docker. Think of it like shipping your entire test setup in a standardized package. This makes things incredibly consistent, so everyone on the team is testing under the exact same conditions, preventing those frustrating "it works on my machine" issues. Plus, containers isolate each other, stopping any conflicts between tests and making it way easier to scale up our testing process by just spinning up more of these boxes. Okay, let's talk about service virtualization, unlocking really powerful tools for testers. Think of service virtualization as creating a perfect clone of a service, complete with all its quirks, so you can test your application without actually needing the real thing to be running. It's like building a stand-in. Mocking is a bit simpler. It's basically replacing a dependency with a controlled fake that gives you specific responses. This is great for testing smaller parts of your code in isolation. There are lots of cool tools out there to help, things like Vagrant and Wiremock can make service virtualization easier, and Mockito is fantastic for mocking objects in Java. Do you have any questions about these approaches? Let's talk about database testing. It's super important for any application that relies on storing and managing data. As a test automation engineer, we don't just check if the data looks right. We need to make sure it's consistently accurate, reliable, and performs well. This includes things like making sure relationships between tables are correct, preventing malicious SQL commands from sneaking in, and checking how quickly the database responds when lots of requests come in. Tools like SQL Unit and DB Unit can really help us automate these checks, alongside techniques like integrating database interactions into our Selenium test or writing custom scripts to handle more complex data validation scenarios. Okay, let's talk about how we can bring the power of SQL into our test automation. It's not just for database management, it's a fantastic way to really boost your tests. You can use SQL to quickly check if changes made by your application have been saved correctly in the database. Plus, you can generate realistic test data and pull out specific metrics like how many users are registered or what the average order value is to analyze your results. Don't forget about parameterized queries to keep things secure. Okay, so let's talk about making sure our automation actually works and is easy to keep going. It's more than just writing some scripts, it's about building them in a way that makes sense long term. We want things to be easy to understand, change, and reuse small pieces of code that do one thing really well. It's also super important to manage our test data consistently so we don't get unexpected results. And finally, good reporting helps us quickly spot problems when tests fail. Okay, let's talk about building a solid plan for your automation efforts. It's really important to think beyond just writing the tests themselves. First, you need to decide what needs to be automated, which features are most critical, and where will automation have the biggest impact. Then, you'll want to pick an approach like whether to use a keyword-driven framework or something else that fits your project. Don't forget about test data. You'll need a strategy for how you generate and maintain it. And finally, make sure you have a plan for your environment so everything runs consistently. A great strategy isn't static, it evolves as you learn more. Okay, let's get down to brass tacks. How do we prove that investing in test automation is worth it? It all comes down to calculating the return on investment, or ROI. The basic formula is pretty straightforward. You take the difference between the benefits and the costs, divide it by the total costs, and then multiply by 100 to get a percentage. Essentially, we're figuring out if the savings from automation outweigh the initial investment. Benefits can include fewer bugs making their way into production, faster release cycles because automated tests are running consistently, and happier customers due to a more stable product. The costs will be things like buying the tools, training your team, and maintaining the scripts. It's really important to try and put numbers on these benefits. How many defects have you reduced? How much time is being saved manually? And don't forget to include a table of common benefit categories and associated metrics for reference. A simple example can illustrate this. If automation saves you 20 hours per week and testing costs $50 an hour, you're saving $48,000 a year. Then, subtracting the cost of the automation tool will give you your ROI. If you want to dig deeper into specific calculations for your project, just let me know. Okay, let's talk about keeping your automated tests happy and healthy. It all starts with managing your test data. If you're using real customer data, you need to be careful about privacy. That's where masking or anonymization comes in. Synthetic data is another great option. It lets you create exactly the data sets you need without exposing sensitive information. And remember, it's really important to maintain multiple versions of your databases so you can easily roll back if something goes wrong. Tools like Git can even help with this. Consistent test data will drastically reduce those frustrating false positives and make sure your automated tests are actually reliable. Okay, let's talk about version control and specifically how it relates to our tests. Here, a similar system lets us work on different versions of our automation code simultaneously without messing up the main codebase. We do this through branching. A branch is essentially a copy of your project where you can experiment with new features or fix bugs in isolation. You create a branch, make your changes, and then when everything's ready, you merge those changes back into the main version. It's like creating a separate timeline for your testing work. Merging brings all those changes together safely. Occasionally, you might run into conflicts if two branches have made conflicting changes to the same part of the code. That's where careful manual resolution comes in. Mastering branching and merging is absolutely key when working with others on test automation projects. Okay, let's talk about Git, because honestly, if you're a test automation engineer, you need to know this stuff. Git is our go-to version control system, and these are some of the most important commands you'll use regularly. First up, git clone. That's how you download an existing repository onto your computer. Then there's git add, which tells Git you want to include changes in your next commit. Git commit m is where you write a short message describing what you changed. You'll also frequently use git push to send those commits to the remote repository and git pull to get updates from others. Creating branches with git checkout b lets you work on new features or bug fixes separately without affecting the main codebase. Finally, if you need to combine changes from different branches, use git merge. Commit often, write good messages. It'll save you ton of time later. Okay, let's talk about managing our test environment. It's super important to understand that we don't just run tests on one single setup. We often need to work with different environments like development, quality assurance, staging, and eventually production. Knowing what each environment is used for development for initial coding, QA for functional testing, staging for final acceptance checks before release, and production where the actual users are helps you choose the right environment for your tests. And crucially, we need to manage how these environments are set up, and that's where configuration management tools like Ansible or Chef come in handy. They let us automate everything from setting up servers to installing software, ensuring that every environment is consistent. Plus, using infrastructure as code, basically defining our infrastructure with code, makes things even more predictable. Finally, don't forget version control. Keep your configurations alongside your test script so you can track changes and easily roll back if something goes wrong. Okay, so let's be honest, writing tests that work across all * environments can be a huge headache. The problem is when your scripts are hard-coded with specific settings like database names or file paths. It's incredibly difficult to maintain and update those tests whenever something changes in an environment. The good news is there is a fantastic solution: parameterization. Instead of putting those values directly into your code, we create variables that represent the correct settings for each environment. Think of it like having a central configuration file or system where you can easily swap out environment-specific details. This makes your test much more reusable and easier to update, ultimately reducing test failures and making deployments smoother. Okay, let's talk about code review and how SonarQube fits in. As a test automation engineer, you don't just want your test to pass, you need to ensure the underlying code is solid too. SonarQube is an amazing tool that continuously analyzes your codebase for potential problems, bugs, vulnerabilities, even things like overly complex code. It's like having a constant quality check. Think of it as a way to proactively identify issues before they become bigger headaches. It uses static analysis, meaning it examines the code without actually running it, and has a really customizable rule engine so you can tailor it to your specific project's needs. Plus, integrating it into your CI/CD pipeline means those checks happen automatically with every change, which is fantastic for keeping things moving smoothly. I'll show you a tiny snippet of an example rule just to give you an idea of how it works. Okay, so let's talk about continuous delivery. It's a really important part of being a modern test automation engineer. Basically, it's all about getting software into the hands of users faster and more reliably. Think of it like an assembly line for your code, but with automated tests built in at every step. The core idea is that automation drives the delivery process. We need to ensure our pipelines are running automated unit tests, integration tests, and even end-to-end tests whenever there's a change. Tools like Jenkins or GitLab CI help us build these automated workflows. And by moving testing left, meaning doing it earlier in the development cycle, we can catch problems much faster before they become major issues. Okay, so let's talk about keeping your automation running smoothly. It's not just about building the tests. A solid maintenance strategy is absolutely crucial. First, we need to regularly review our scripts. Think of it like a health checkup every few months. Then, always use version control. Git is your best friend here. Commit often and make sure those commit messages are descriptive. Don't forget to document everything: test cases, steps, expected results, and update that documentation as things change. Also, keep an eye on any external dependencies like browser versions or Selenium. Plan for updates so you don't get caught off guard. Finally, regularly retire tests that are no longer needed and reactivate ones that have come back into use. Okay, so flaky tests are a real headache in automation. They're like the unreliable friend that sometimes works, sometimes doesn't. They can be caused by all sorts of things: problems with your network, changes you haven't accounted for in your code, or even just timing issues. Let's talk about how to tackle them. First, it's important to figure out which tests are flaky, and then really dig into the root cause, what's triggering those inconsistent results. Retries with timeouts can sometimes help, but you need to be careful not to just hide the problem. Ultimately, a stable test environment and simplifying your tests through refactoring are often the best long-term solutions. Okay, let's talk about tackling those tricky bugs in our automation scripts. It's totally normal for things to go wrong. We'll cover some of the most common reasons why your tests might fail, like using incorrect data, differences between environments, or simple logic mistakes. Then we'll look at how to actually find and fix these problems. Things like logging and assertions are super helpful here, as is stepping through your code with a debugger. Finally, remember that isolating the problem by commenting out sections of code and asking for help when you need it can make all the difference. Okay, let's talk about running tests in the cloud. As a test automation engineer, you'll be spending more time managing tests within platforms like AWS or Azure. It's all about treating your testing environment just like any other part of your application, with infrastructure as code, using tools to make things repeatable and scalable, and choosing the right cloud-native services for executing those automated tests efficiently. Don't forget security and keeping an eye on costs too. Okay, let's talk about measuring the effectiveness of our automated tests. It's not enough for them to just pass. We need to understand how well they are passing and where there's room for improvement. We look at things like pass rate, which tells us how much of our test suite is running successfully, and test coverage, showing us what parts of the application are actually being tested by automation. Then we consider execution time. Are our tests taking too long to run? Finally, defect density helps us spot potential issues early on. And to keep track of all this, we generate reports like daily summaries that give a quick snapshot of test results and key metrics, detailed test result breakdowns for troubleshooting, and trend analysis charts so you can see if things are getting better over time. Okay, let's talk about how Agile testing changes things for test automation engineer. At its core, Agile is all about working closely with developers and prioritizing delivering value to the customer quickly. We don't just test at the end of a project, we integrate testing throughout the entire development process. Automation is key here. It helps us run tests more frequently and efficiently, allowing us to find bugs early on. Techniques like test-driven development and behavior-driven development are really important for ensuring everyone's on the same page and delivering features that meet customer needs. Okay, let's talk about how we're changing the game with test automation. We're moving beyond just finding bugs at the end, it's all about being proactive. Shift left means bringing testing *or layer * into the development process, embedding tests right within your code. This gives you faster feedback and makes collaboration between developers and testers much smoother. Think unit tests and integration tests. Then there's Shift Right, which focuses on validating the entire system after everything's built, making sure it performs well, is secure, and easy to use. It's about that final quality check. Let's talk about keeping our automated tests safe and compliant. It's not just about catching bugs, it's about protecting data and following the rules. We need to think about masking sensitive information, like customer details, using fake or anonymized data instead of the real thing. Access control is super important too, making sure only authorized people can access systems used by our tests. And crucially, we have to avoid storing passwords directly in code. Instead, let's use secure ways to manage secrets. Finally, understanding regulations like GDPR or HIPAA is essential so that our automated testing aligns with legal requirements. Regularly reviewing our setups and integrating security checks throughout the process will make sure everything's running smoothly and securely. Okay, let's talk about how we figure out how long it will take to automate our tests. It's surprisingly important. First, we can rely on the expertise of experienced automation engineers. They usually have a pretty good sense for what's involved. But remember, their estimates aren't perfect, typically around 30 to 50% accurate. Another approach is to look at similar past projects and use that as a guide. Just be sure to adjust for any differences in the complexity or scope. Then there's parametric estimation, which uses some statistical relationships to help us. Finally, often the best way is to combine several techniques like expert judgment with analogous estimation to get a more refined estimate. And remember, it's really important to account for things like setting up the test environment and maintaining those automated tests. Okay, let's dive into some of the awesome accessibility testing tools out there. We have Axe from Dick Systems, which is a really popular browser extension, and Node.js library. It's super fast at finding problems with your website based on WCAG guidelines. Then we have Wave, also from Dick, which is like a screen reader simulator. You can see exactly how content looks to someone using assistive technology. And last but not least, Paylivery, a command line tool that's fantastic for integrating into your development workflow and CI/CD pipelines. Using these tools will help catch accessibility issues early on and make sure your website is usable by everyone. Okay, let's talk about getting our tests out there specifically across different platforms. Cross-platform automation is all about writing tests that work on iOS, Android, and even web browsers without needing to rewrite everything from scratch for each one. We often use tools like Appium and Selenium to do this. It's helpful to utilize device farms or emulators so we can simulate a really wide range of devices and operating system versions. A key part is using conditional logic in our tests because each platform has its own way of doing things, different UI elements, different behaviors. And let's not forget accessibility. Making sure the app works well for everyone, regardless of their needs across all those platforms, is super important. Okay, so let's talk about building a strong foundation with our automation framework. We're going for a hybrid approach. That means we'll be using both manual testing and automated tests together. Think of it like this: human testers are great at finding unexpected issues and dealing with complex user flows, while automation handles the repetitive stuff like regression tests and ensuring everything works consistently. We'll need tools like Selenium or Playwright for our UI, Postman or Rest Assured for API testing, a good test management system to keep things organized, and of course integration with our CI/CD pipeline so tests run automatically. Okay, let's talk about making our tests even more resilient, specifically by adding retry logic. Think of it this way: sometimes things just don't go smoothly in the digital world, right? A temporary network glitch or a server having a little moment can cause tests to fail unexpectedly. Retry logic is all about giving those tests a second chance. It's not always enough to simply mark a test as failed. We need to try again. We'll cover some common strategies like fixed delays, exponential backf, which increases the wait time between retries, and setting a maximum number of attempts. The key is to choose a strategy that balances reliability with avoiding overwhelming failing systems. Okay, let's talk about generating test data. As test automation engineers, we often need a lot of data to run our tests effectively. That's where tools like Mockaroo and Faker come in. Faker is a popular Ruby library that can create things like fake names, addresses, and phone numbers, basically anything you need for realistic testing. Mockaroo is a bit more powerful. It's a web app and API that lets you build completely custom datasets with specific distributions. Think about needing data representing different age ranges or income levels. Mockaroo makes this super easy. Using these tools saves us a ton of time, protects our privacy by avoiding real data, and helps us cover more edge cases in our tests. Let's take a quick look at how you might use Faker in Python to generate a fake name. Okay, let's talk about dynamic web tables and pagination. They're a frequent hurdle in UI testing. The key is to really understand the structure of these elements first. That means identifying what makes up the table, like the headers and data cells, and finding those control buttons for navigating through pages. We can use things like XPath or CSS selectors to reliably pinpoint specific rows and data points. When it comes to pagination itself, you'll need logic to move between different pages, whether that's clicking next repeatedly or entering a page number. And of course, once you're on a particular page, it's important to verify that the data is correct. A good tip here is using relative locators, things like Romanus 1 and Comanus 2, that are less likely to break if the table structure changes slightly. Okay, let's talk about how we can make sure our apps look fantastic across the board. We're going to focus on visual testing, essentially checking that everything looks right from a user's perspective. Tools like Percy and Applitools are designed specifically for this. Percy is a really straightforward screenshot comparison tool. It captures snapshots of your UI, uploads them to Percy, and then instantly flags any differences compared to a baseline. Applitools takes things a step further, using AI to detect even minor visual tweaks that a regular pixel-by-pixel check might miss. They can handle different devices, browsers, and resolutions all at once, making the testing process much more efficient and reliable. Think of it as catching those little oops moments before they impact your users. Okay, let's talk about how we can really dig into our test automation. We want to make sure we're not just running tests, but actually testing everything. That's where code coverage comes in. Yocoko Istanbul is a fantastic tool for this, especially if you're working with Java. Essentially, it tells us what percentage of our code is being touched by our automated tests. It works by instrumenting the code, meaning it adds some tracking to help identify which lines are executed. Then, Istanbul takes over and generates beautiful reports that give us a clear picture of where we're doing well and where there might be gaps in our testing strategy. It integrates seamlessly with tools like Maven and Gradle, making it super easy to add to your continuous integration process. Okay, let's talk about how we integrate automation into our CI/CD pipelines. It's a really important shift. Instead of just testing at the very end, we're running tests throughout the whole process. The main benefit is that you get much faster feedback on your code changes, which helps catch bugs earlier and keeps things moving smoothly. Automation also frees up our QA team to focus on more complex tasks like designing better test strategies. Think of it this way: every time someone commits new code, a bunch of automated tests run automatically, checking for issues as they go. We usually start with unit tests that check individual pieces of code, then move on to integration tests that make sure different parts work together correctly, and finally end-to-end tests that simulate how a user would actually use the software. Okay, let's talk about keeping a close eye on your automated tests. It's not enough just to run them, you need to understand how they're running. We want to track things like overall pass rates. Are we generally succeeding? We also look for trends. Are those numbers improving or getting worse over time? And don't forget about test duration. If tests are taking longer, that's a clue something might be wrong. Finally, set up alerts so you know immediately when a test fails. It's all about catching issues as quickly as possible. Okay, let's talk about distributed test execution. Think of it as a way to massively speed up your testing process. Instead of running all your tests on just one machine, you spread them out across multiple machines. We call those clusters. An agent is like the translator between the main controller and each individual machine doing the work. And that main controller, often called an orchestrator, is responsible for keeping everything organized and making sure the tests run smoothly. It's a game changer because it lets you test faster, use your resources more efficiently, handle failures better, and even mimic different user experiences like testing on different devices simultaneously. Okay, let's talk about extending our test automation frameworks with custom listeners and hooks. Think of listeners as event handlers. They react when things happen during a test, like it starting or an assertion failing. They can do all sorts of cool stuff like log information to a file or even send you a notification. Hooks are basically functions that get called at specific points in the test process before, after, or even during a test case. They're super flexible for injecting custom logic. For example, say you want to track every time an assertion fails and capture exactly where it went wrong. You could create a listener that specifically looks for failed assertions and then call a hook function to log all the details. This lets us really tailor our tests to precisely what we need. Let's talk about test automation for SaaS. It's a really important area. These platforms are constantly evolving, so you need to be able to quickly verify changes and integrations. A big part of that is testing the API, which are at the heart of almost everything these days. Then there's the user interface. You want to make sure your automation can simulate how users actually interact with the system. And don't forget performance. SaaS platforms need to be able to handle a huge number of users at once, so we need to test how they perform under pressure. Finally, always keep an eye on those integrations. Making sure everything talks together smoothly is crucial. Okay, let's talk about end-to-end testing, or end-to-end testing as it's often called. Essentially, end-to-end tests are like simulating a real user going through your entire application from beginning to end. Think of it as a full journey for the user. It's different from UI testing, which focuses on individual parts of the app. Instead of just checking one button or form field, end-to-end tests cover all the interactions between those components and even with external services like databases or API. The main benefit is that you catch integration problems early before they become big headaches, and it can actually reduce the amount of manual testing needed in the long run. Okay, let's talk about how we use the command line as test automation engineers. It's absolutely essential to be comfortable navigating and running tests through the shell. It gives you so much more control than just a GUI. We'll cover some fundamental commands like cd to change directories, ls to list files, and grep for searching within logs. There are also powerful tools like Zogs that can help us handle large numbers of files efficiently when automating builds or tests. And if your project uses a build system like Maven or Make, you'll be using those commands frequently too. It's really about building up your comfort and confidence with the command line. Okay, let's talk about scaling your Selenium tests. Selenium Grid is a game changer when you need to run more tests faster. Basically, it lets you spread your tests out across multiple computers instead of just one. This means you can dramatically cut down on the time it takes to get a full picture of how your application performs. Think of a central hub that manages everything and worker nodes actually doing the testing all running in parallel. It's about efficiently using available hardware and making sure your tests aren't bottlenecked by a single machine. Okay, let's talk about how cloud device farms can really level up your test automation. Essentially, instead of needing a huge collection of physical phones and tablets which is expensive and takes up tons of space, you can use services like AWS Device Farm or Sauce Labs. These platforms give you access to thousands of real devices running different operating systems and browsers. This means you get much more accurate results because your tests are actually being run on the same hardware your users will be using. It also speeds up the testing process dramatically and gives you great data to understand where problems might be. Okay, let's talk about test automation reporting dashboards. Think of them as your central command center for all things testing. They're not just pretty charts, they provide crucial insights into the health and effectiveness of your automated tests. A good dashboard will start with an executive summary giving you a quick snapshot of how many tests passed, failed, or were blocked overall. Then, you'll want to dive deeper into test status breakdowns, which often use visuals like bar graphs to show exactly what's going on. Tracking trends over time is really important. It helps you spot regressions, those sneaky bugs that creep back in after being fixed. And of course, you need a link to your defect tracking system so you can see how many issues are being reported and resolved. Don't forget to include the status of your test environments too. Things like server availability can really impact test results. Okay, so let's talk about event-driven test automation. Instead of writing tests that follow a specific path from start to finish, we're looking at how our tests can react to things happening inside the application. Think of it like setting up listeners components that are waiting for specific events, like a button click or a form submission. A workflow engine then manages these listeners and executes the appropriate actions when an event occurs. This makes testing much more flexible and adaptable, especially in applications where things change dynamically. It's about letting the application drive the test, rather than forcing the test to follow a rigid script. Okay, so let's talk about automating tests for hybrid mobile apps. These are the ones built using frameworks like React Native or Flutter. They're super versatile. But there are some specific challenges with these types of applications compared to native development. One big thing is that iOS and Android can behave differently, and you have lot of different devices out there to test on. So, we need strategies that account for those differences. We'll look at things like using the tools specifically designed for the framework itself, or leveraging cross-platform tools combined with device emulators. And don't forget about cloud-based testing. They can really help you manage all of this. Okay, let's talk about keeping your automation code clean and manageable. Refactoring isn't just making it look nice, it's vital for long-term success. As tests grow, they can become complicated and hard to work with. So, the first step is spotting what we call code smell, things like repeating yourself or functions that are way too big. Then, make small changes one at a time, always testing after each adjustment. Applying solid principles and DIY don't repeat yourself can also dramatically improve your code structure. And if you're using TDD, keep revisiting it during refactoring to ensure everything still works as expected. It's all about making sure your tests are easy to understand and maintain a continuous effort that pays off big time. Okay, let's dive deeper into advanced locators. When it comes to test automation, you can't just rely on simple ID or classes, especially as websites get more complex. XPath is like a GPS for the DOM tree. It allows us to navigate through all the elements and find exactly what we need using paths. CSS selectors are also great for targeting specific elements based on their attributes, styles, and relationships. They are often a bit more concise than XPath for simpler cases. Remember, the goal is always to pick the most robust and maintainable locator possible. Okay, so let's talk about testing PWA. These apps are really changing the game for mobile experiences. They act like native apps but live in your browser. Because of this, we need a solid test automation strategy. There are some unique things to consider compared to regular app testing, like service workers which handle offline functionality and web manifests that manage updates and splash screens. We also need to make sure push notifications are working correctly and that the PWA is properly integrating with native device features through API. When it comes to actually automating these tests, we often use end-to-end tests to simulate user journeys, component tests to focus on specific elements, and API mocking to avoid complex backend dependencies. Okay, let's talk about documentation. It's absolutely vital for any test automation engineer. Think of it as a roadmap for your automated tests. We need to document everything thoroughly. Our test cases, detailing exactly what we expect and how to achieve it, the scripts themselves with clear comments explaining their purpose and logic, our automation frameworks design how it's built and organized, and even the test environments, so others can replicate them easily. Finally, we need release notes specifically for automation changes. Consistency is key here. Use a template across everything to make things easy to follow. And remember, documentation isn't static, it needs to evolve as your automation suite grows. Okay, so when building test frameworks, it's super important to avoid repeating yourself. That's where reusable utility functions come in. Think of them as little code helpers that handle common tasks like waiting for an element to appear on the page or generating random data. Using these avoids a ton of duplicated code, makes your tests easier to maintain because you only have to change something once, and ultimately, they make your test scripts much more readable. Let's look at an example. This wait for element function waits for a specific element to appear on the page within a certain time frame. It's a small but powerful tool that can save you a lot of time. Okay, let's talk about how we can really make test automation work hand in hand with DevOps. The core idea is to get test automation asterisk into asterisk the pipeline, not just at the end. Think of CI/CD pipelines. They're your new best friend. Every time someone commits code, automated tests run automatically as part of the build process. We also need consistent environments, so infrastructure as code tools like Terraform help us create and manage those test environments automatically. And don't forget about data. Automating test data management is huge for reducing errors. Finally, make sure everyone knows when things fail. Integrated reporting and automated notifications keeps everyone in the loop. Okay, let's talk about ensuring your API works seamlessly together. We're going to dive into Pact, a fantastic tool for API contract testing. Think of it as a formal agreement between the parts of your system that talk to each other. It helps teams collaborate better and catch issues early before they cause major headaches in integration tests. Pact essentially works by having consumers like your front-ends create specs describing exactly what data they expect from the back-end. The back-end then implements the API based on those specs, and Pact runs automated tests to make sure everything matches up. This way, if something changes on either side, you'll quickly know about it. It's a really powerful approach for building robust and reliable API. Okay, so let's talk about testing in service-oriented architecture. As automation engineers, we're seeing these complex systems everywhere, and they require a slightly different approach than traditional monolith testing. The key thing to remember is that SOA is all about reusable services talking to each other. We need to focus on making sure those contracts, the agreements between the services, are solid. This means verifying data formats match what's expected, and also ensuring messages are handled correctly as they move from one service to another. Integration tests are a must, simulating how the whole system works end to end, often using tools like YMock to stand in for the actual services. And of course, API testing is absolutely critical, really digging into each individual API endpoint to make sure it's working as intended. Tools like Postman and SoapUI can be invaluable here. Okay, let's talk about testing IoT devices. These things can be tricky. Because they're spread out everywhere and often have connection problems, we need a special way of automating the tests. Think about times when your internet goes down. That's exactly what we want to simulate. We also need to account for all the different versions of firmware and hardware each device might use. And importantly, we have to make sure the data coming from the sensors is actually correct. Finally, security is a big deal, so we'll want to automate those checks too. Tools like Robot Framework can really help us build strong automation frameworks for this type of testing. Okay, let's talk about handling those inevitable hiccups in our automated test, errors and exceptions. It's crucial because a single crash can derail an entire test suite. Without good strategies, you end up with incomplete results, potentially corrupted data, and a major headache when trying to figure out what went wrong. There are a few key types of problems we might encounter: runtime issues like elements not being found, assertion errors where the expected outcome doesn't match reality, and even problems originating within the testing framework itself. To deal with these, we often use try-catch blocks to wrap potentially problematic code sections, allowing us to catch exceptions and gracefully handle them. It's also really helpful to include detailed error messages in our assertions so we can quickly identify the source of the problem. And don't forget Logi, it's your best friend for tracking down those elusive errors. Okay, let's talk about scheduling tests in a continuous integration and continuous delivery environment. Think of it as making sure your tests run at just the right time, not too early, not too late. It's really important to trigger them automatically whenever code changes are made, like when someone pushes new code to the repository. We want to make efficient use of our testing resources, so parallel execution is key, running multiple tests simultaneously. And it's good practice to prioritize your tests. Maybe start with quick smoke tests and then move on to more comprehensive regression tests. Finally, make sure you have enough computing power available, especially if you're running a lot of tests. Your CI/CD tool like Jenkins or GitLab will be key in automating this scheduling process. Okay, let's talk about handling files in our automation tests, specifically uploads and downloads. It can be a bit of a headache because it's not always straightforward. The main thing to keep in mind is that file operations often rely on post requests for uploading and get/post for downloading. We'll primarily use tools like Selenium to control the browser and simulate these actions. We'll focus on selecting the right file, making sure the form data is correct, and then verifying that the download completes successfully. Don't forget about error handling. Think about what could go wrong, like an invalid file type or a network problem, and build your tests to gracefully handle those situations. Okay, let's talk about keeping our test data safe. As test automation engineers, we frequently work with sensitive information, so it's super important that we handle it securely. Think of encryption as like putting a lock on your database. Only those with the key can access it. We also need to use techniques like masking or tokenizing real data when we're testing in environments that aren't live, and making sure our data storage is properly protected. And don't forget about using HTTPS for all communication. Think of it as a secure tunnel. Ultimately, protecting test data isn't just about compliance, it's about building trust and respecting user privacy. Okay, let's talk about test automation specifically for CRM and ERP systems. These are huge, complex pieces of software that are vital for many businesses. The main challenge is that they're incredibly intricate, with tons of moving parts and data flowing back and forth. We need to ensure everything works seamlessly, which is where automation comes in. It's really important to focus on end-to-end testing, simulating real user scenarios, especially when it comes to things like sales processes or inventory management. When choosing tools, Selenium, Cypress, and Playwright are popular choices. Picking the right one depends on your team's skills and what you need to test. And don't forget about API testing. These systems often rely heavily on integrations, so validating those connections is key. Okay, let's talk about how test automation engineers fit into the Agile workflow. It's more than just writing code, it's being part of the team. During sprint planning, we work with the developers to figure out what needs to be tested and estimate how long it will take to automate those tests. Daily stand-ups are a quick way to stay informed about progress and potential issues. The sprint review is our chance to show off the automation we've built and get feedback from stakeholders. And finally, the retrospective, that's where we honestly talk about what worked well and what could be better, helping us improve as a team over time. Okay, let's talk about how we test cloud native apps. These applications are built in a really different way than traditional software. They are often made of lots of tiny pieces that work together. That means our testing needs to be flexible and able to handle these changes. We need to think about things like the constantly shifting infrastructure, making sure all those microservices talk correctly to each other, and ensuring our tests can scale up when a lot of people are using the app and still recover if something goes wrong. Some popular tools we use include service virtualization, which lets us pretend that some of these services aren't really there while testing, API testing to check how the different pieces communicate, and running our tests inside containers so they match the real environment as closely as possible. Okay, let's talk about mocking and stubbing in microservice testing. Basically, these techniques help us isolate our tests from real services so we don't depend on them being up and running or behaving perfectly. Mocks are like creating fake versions of those services that you can control. You tell them exactly what to return. Stubs, on the other hand, are simpler. They just provide predefined responses to calls. It's helpful to think about when you'd use each one. Mocks are good for verifying interactions and error handling, while stubs focus on ensuring your code works correctly with simple dependencies. Okay, let's talk about load balancing in test automation. Basically, we want to see how our application holds up when it gets lot of traffic, think hundreds or even thousands of users hitting it at once. We use different types of tests like spike testing, where we suddenly ramp up the user load, and soak testing, which is a longer-term test to check for stability issues over time. It's important to plan these scenarios carefully, using tools like JMeter or LoadView, and then automate the whole process, designing the tests, running them, monitoring what's happening, and finally analyzing the results to find any performance problems. Thank you for watching.